Business undertakes high-risk investments as minimum expected 70% cost capital. The balance rate is has the following expected cash flows. Okay, year zero, negative 50,000, year one, year two, year three, year four. Okay, so we've asked calculate the NPV of the project if the cost of capital is 15%. Calculate the NPV of the project if the cost of capital is 20%. Use the NPVs you've calculated to estimate the IRR of the project. So, colleagues, this topic is on capital budgeting or investment appraisal. Please pay attention because you're going to be learning this next year in two courses. So, this is where you need to be very attentive. So, capital budgeting or investment appraisal is how a business decides on which projects to invest in. Okay, these are techniques to see, okay, should I invest in this project? Should I invest in this other project? You want to see if the projects are viable. So there are actually five types of techniques, but here in this question, we're going to use the two most commonly used ones. It's the net present value technique and the internal rate of return technique. So the net present value, we'll start with the net present value technique. All right. What happens is whenever you are planning to invest in a project, you're always going to forecast some cash flows. Okay. So these cash flows from year one to year four, these are your forecasts. Okay. These are what you expect to make basically. Okay. Year zero represents the first day of year one, and the costs. Why this 15,000 is in brackets is because it's representing a negative cash outflow, meaning this is the cost of the investment, 50,000. Okay, you pay 50,000. After you pay that 50,000, you've invested your money. At the end of year one, you expect to make 18,000. End of year two, you expect to make 25,000. End of year three, expect to make 20,000. End of year four, expect to make 10,000. Okay, so these are just our forecasts. So what's going to happen with the net present value? This money will be receiving in the future. Okay, from year one to year four, all this money that we're going to be receiving, we're going to convert it into today's value. Okay, colleagues, did you know there's a way how to convert money in the future into today's value? Did we know that? Madam Catherine, did you know that? Let's see. Mr. Emmanuel, did you know that? Mr. Kasono, Mr. Chimonia. Yes, that's what we're going to do here. Money which we're going to receive in the future, we're going to say what is its value today. Okay. So the net present value basically is just your cash inflows minus your cash outflow. Okay. That's what we're doing. Cash inflows minus cash outflow. Okay. Then if you get a positive net present value, that represents profits or it represents gains for the investment. A negative net present value, it means the investment will give you a loss. A net present value of zero, it's like you've broken even. Okay, colleagues, with the net present value, okay, it's just your cash inflows, the money that will be coming in, you convert it into today's value and you compare it against the cost. Okay, colleagues. So now we're going to see how we're going to convert money in the future into today's value. That is what we call discounting. Okay, discounting is just converting money in the future into today's value. Okay, so you always have to use a discount rate. Okay, discount rate. So your discount rate is what you call the cost of capital. Okay, the cost of capital, in simple words, is just the return you need to give the person who has financed you. For example, if you borrow me a 1,000 kwacha and you say interest, I want interest at 10%, that interest at 10% is my cost of capital. Okay, because that's the return I need to give you for financing me. Are we okay with that? Madam Yvonne, Mr. Vincent, Miss Madam Sylvia, Mr. Chimino? Cost of capital is the return you need to give the person who's giving you money. Okay. So this will be our discount rate. Okay. So this is the formula how you convert money in the future into today's value. Future value, present value, sorry. Present value equals future value, open brackets, 1 plus r to the power negative t. T just represents time, r is the discount rate. Okay. So we'll do it like this. So the way you can solve this, you can make a table or you can solve do the tabulations individually. But here, let me just show you how we can do it. So in the table, okay, if you make your table, your first column will have your year. It's negative, yes. Other books, you're going to see future value over 1 plus r to the power t. Okay. If you remember the laws of indices, okay, whenever you have a negative index, you you can get the reciprocal. Okay. So these two are the same. So which one are we comfortable with, colleagues? This one on the right or the one on the left? Okay. So in this next column, we need to put our discount factor. Basically, our discount factor is this 1 plus r to the power negative t. That's the discount factor. Okay, that 1 plus r to the power negative t is the discount factor. Our future values are here. Okay, the future values are already here. So our discount factor 1 plus r to the power negative t. Our discount rate, as I said, r represents the discount rate, and the discount rate is your cost of capital. So this 15%, oh, so here it will be 1 plus r, you just substitute it with 15%. So 15% in the decimal form is 0.15. So 1 plus 0.15, 1.15. So this discount factor is going to be applied throughout year 1, year 2, year 3. The only because that's the discount rate. The cost of capital is used as your discount rate for investment appraisal. Oh, you're not convinced with that, madam? Okay, the question I said here, if the cost of capital is 15%. Yes, yes, yes. Uh, mm. Sir, you are moving, you are ahead of us. Well, how do we go to the second part? We haven't even started with the first part. Mm-hmm. Yeah. Okay, when I said, maybe it's the way I said using it throughout where it has caused confusion. When I said we're using it throughout, I mean we're going to be multiplying it with each of these future values here. That's what I meant when I said we use it throughout. Okay. Now, as I said, the only thing that will be changing is the negative t. Okay. The negative t represents the year. Okay. So in year zero, which is the first day of year one, it's to the power negative zero. In year one, it's to the power negative one. In year two, power negative two. Year three, power negative three. Year four, power negative four. Are we okay with this, colleagues? If I'm going too fast, you say, Sir, you're going too fast. This is a new topic. You want to grasp it? Yes, colleagues. All right. Now, there are also tables you can use. Colleagues, do you want us to use the tables so that we don't need to be doing these tabulations here? The table will give us the values here. Okay, since it's quiet, it means no. Okay, so one point. Mhm. Okay. Mm-hmm. Discount rate. It's not 15% of anything. Okay. It's not. It's not 15% of anything. Yes. You get the 15% in this formula for present value plus future value 1 plus r. When there is r, you substitute with 15%. Okay. If it was 5% here, then it means when there's r here in this formula, we substitute with 5%. Is that okay, sir? Let's see, where do I now start from? I was saying that. Okay, wait, what was your question again, sir? Basically, so I know where to start from. Yes, yes. This 15% in decimal, 15% in decimal, 15% in decimal is 0.15. Yes. Okay. Okay. So 1.515 to the power negative 0, that is 1. So the present value for year 0, present value, as I said, future value, although this is truly not a future value because this is what you're paying that day. Okay. So it's a negative 50,000 times 1. We get negative 50,000. Okay. We've just multiplied our value, this negative 50,000, with this 1 here. So we get negative 50,000. Okay, we're just going to be multiplying this FV column with this 1 plus R to the power negative T column. Okay, that's all that's going to be happening here. So we go to year 1, 1.15 to the power negative 1. What do we get? Hmm. 1.15 to the power negative 1. Okay, so we'll use 0.87. 18,000 times 0.87. We're doing 18,000 times 0.87. Okay. So this 18,000 which we'll receive at the end of year 1, today it's 15,660. 1.15 to the power negative 2, what do we get? Okay. 25,000 times 0.76. Okay, let me use this paper here because the figures. Yes. Is this much better, colleagues? Okay, so year 2, okay, year 3, 1.15 to the power negative 3, you get 0.658. So you say 20,000 multiplied by 0.658, what do you get? Oh yeah, actually I've even got the values there. Year 4, 1.15 to the power negative 4, 0.572. So say 10,000 multiplied by 0.572, we get 5,720. So there are many ways you can do this. You can total up the inflows. You total up the inflows, you see what number you get, and compare it against the 50,000 to see if you get a positive or negative value. The other way you can do it, like with this table, just add these present values. You say negative 50,000 plus 15,660 plus 18,900 plus 13,160 plus 5,720. When you add these numbers, you get a positive 3,440. Okay. A positive 3,340. And as I said, with the net present value technique, if your net present value is positive, it represents gains or profit to the project, so you accept. If your net present value is negative, it's representing a loss to the company, so you reject. So in this case, since our net present value, although that's for part C, but since our net present value is positive, so we can accept this project. Any questions? Is it consumer friendly? Mm-hmm. Yes, break even. And you really wouldn't want to invest in a project that will make you break even, right? You wouldn't want to invest in a project that will make you break even. Any questions? Will the formulae be given to us? It's Madam Betha who likes asking that question. Will the formulae be given to us? For the internal rate of return, yes. For the net present value, if we on the table that they're going to give you in the exam, you will see this formula, this 1 plus r to the power negative n. So I think the formula will be somehow given to you. Any questions? Okay, let's try part B. The cost of capital is now 20%. Let's try to solve, colleagues. Let me see. 5 marks, sure. 5 marks. 5, 15, 20. So if, let's see, You're on a D minus, meaning you're somewhere at like maybe at like 48, somewhere there. So answering this one, 48 plus 5, that takes you to 50, 53. You're now in a C. You answer this one, you're on 58. You answer this one, you're on 60. Yeah? You're now entering a B. Have you seen how? Oh, yes. Oh, yes. Now I'm just illustrating how one question can save your life. Okay. All right. Yes. So let's calculate at 20%. You tell me your answers. If you're not sure of what to do, ask. Say, "Sauka, what should I do first?" I help you. Okay. Eh, 1.2. Eh, So there, where there's 1.5, replace it with 1.2. So in real life, when you become a director of finance of a company, the trick is determining this discount rate. Don't over exaggerate it or under exaggerate it, and also these cash flows. Okay, because this is what you are expecting. So do not exaggerate numbers, because you might invest in a project that will, in actuality, give you losses. Okay. And yes, this the IRR, the what is basic what we're doing here is basically finding the IRR also of the project. Okay. So explain once we reach part C. But whenever you're doing the internal rate of return, You have to get two net present values. Okay, one has to be positive and one has to be negative. Yes, are we winning? Okay. Let me see what I got. Negative 1000. But you did the correct thing, sir. So why would your mathematics be wrong? Well, if your mathematics is wrong, but you have done the correct thing. So I believe it should be due to rounding off. That's why our numbers are a bit different. Okay. You've got negative 1410. Okay. Okay. Then don't worry. Yeah. So that is correct. Okay. Any questions? So since the net present value is negative, we reject. Consumer friendly, right? Okay. No, it's about to be. It's about to be, sir. The moment you just start listening to Greek, just say, sir, let's go back to English. Now, for those who are asking, sir, will this be given? Yes, this formula will be given to you. Okay. Let me just translate the formula. Mm-hmm. And that's the NPV with the lower discount rate. Okay. Higher discount rate minus lower discount rate in this bracket, yes. He, right? Mm, it's beepers. It is part of the formula. Ah, yes. Consumer friendly. Or maybe let me use H%. Maybe H% to make life H and L percent. Huh? Let me use L% lower discount rate. So NPV L%. Then when there's H, when there's B, I put H. Does that make life better? Hmm. So H% is the lower discount rate. H% is the higher discount rate. L% is the lower discount rate. Okay. NPVL, net present value with lower discount rate. NPVH, net present value with higher discount rate. Are we okay with that? I'll use L% to make life easy. And this, when we see an L, we can think, okay, low. Mm. So this is the formula for the internal rate of return. Okay. With the internal rate of return, you're going to have two NPVs, two net present values. One should be positive and one should be negative. Okay. So you saw in our earlier tabulations, we found a, a positive net present value and a negative net present value, right? So here, because we're now in part C codings, okay, they're saying use the NPVs to estimate the internal rate of return. So the data we're using for the internal rate of return is from these two NPVs. Okay, the one with 15% and the one with 20%. Okay. So here, which one is the higher discount rate? Yes. So you say H% is 20%. The lower discount rate is 15%. Then next we need to know what is the The net present value with the lower discount rate. What was the net present value with the lower discount rate? Did you write it down? It was that 3,000 we calculated earlier on. Yes. So that is your NPVL percent. Okay. 3,440. Then the NPV with the higher discount rate, you get years. Ish, I'm tired, colleagues. That's why I'm writing like this. Forgive me, forgive. Maybe let me use a word. Let me use a word. Okay, yes. I think like this. This is more clear. So we said L percent, lower discount rate. Let me just substitute L and A. Okay, so L percent is there, 15%. H percent is 20%. Lower and higher discount rates. Then NPV, L percent, we said that was 3,440, right? In NPVH percent, it is you guys found negative 1,000 for what? Yes. So it's just a matter of substitution now. Okay. So when there's L percent, substitute with 15%. When there's NPVL, substitute with 3,440. When there's NPVH, substitute with negative 114. Then now it's a matter of order of operations, paid mass or board mass. So after you've substituted, your expression is supposed to look like this. So the true mathematicians using board mass, which operation do we do first? Which operations will be done first? Mhm. So 20 minus 15. Mhm. Then after that, so you start with this in the brackets here. Let's do it, colleagues. Get our value there. And also here, this in the brackets here. Let's get our value. Mhm. And then also here at the bottom, when you do the subtractions, 3,440 minus negative 1,410. Okay. for 850. Now, here, if you want, you can divide these two first, or if you want, you can multiply the 5 times this 3440, then divide. I usually like to first divide the fraction first. So 3440 divided by 450. Okay, 0.709 times 5%. I know people are wondering, sir, why is it okay to multiply them with percentages like that? Yes, colleagues, it is okay to multiply them with percentages. If you want, you can convert the percentages into decimals, but at the end, you have to reconvert your answer into a percentage. I forgot to mention the internal rate of return. Whenever you hear the word rate, usually it can also be in form of percentages. And when you hear return, it is the money that's coming back to you or your profits whenever you invest into something. So basically, you want to know your return in percentage form. That's all. You want to know your return in percentage form. That's what the internal rate of return is telling you. Is that okay, Madam Yvonne? Mr. Vincent? Madam Sylvia? Yes. Remember, next year, let me even jot down the date. Today is the 24th of April. So next year when we meet, I'll say, remember on the 24th of April, 11:44 p.m., the topic we are doing. And let me see everyone who is here. Because I'm going to be seeing all of you next year. You're all clearing. So I'm going to, yes. So I shouldn't hear if I ask Mr. Kasono next year, not that, sir, I've forgotten. No, sir, we're not accepting that. Okay, then you divide, after dividing, then you multiply 0.709 times 5%. So are you watching a Nigerian movie? You said 0 point what? Huh? Me, I'm getting 3.545. You've converted the percentages into decimals also. Me, when I do 0.709 times 5, I'm getting 3.545, not 0.3545. Yes, just write it like this, colleagues. Why are we converting into decimals here now? Then you just add now 15 plus 3.545. Yes. Excuse me. This is the internal rate of return. Okay. So if you ask yourself, from this project, okay, what is my return that I'm getting from this project? Basically, all these cash flows, what return are they representing? They're representing a return of 18.5%. Okay. And this return is compared with the minimum expected rate of return. Okay. The expected return is 17%, and our project is giving us a return of 18.5%. So it means we should accept, right? Because we are expecting a minimum return of 17%, but our project is giving us a return of 18%.